where our Milky Way ended. They saw a single island of stars, floating in a sea of endless darkness. The cosmos, they thought, was small, still, and eternal. But in 1928, everything changed. Edwin Hubble, working with powerful telescopes and careful observations, made a discovery that shattered that illusion. He found that the universe was expanding, growing larger with every passing moment. Galaxies weren't fixed in place, they were fleeing from each other at incredible speeds. The universe, once imagined as static, was revealed to be dynamic, alive, and restless. That discovery opened the door to a new kind of science, a new way of seeing reality. Then, in 1997, the Hubble Space Telescope carried Edwin's legacy even further. It found something unexpected. The universe wasn't just expanding. It was accelerating. Some invisible force was driving the galaxies apart faster and faster. This mysterious energy became known as dark energy. And it rewrote the cosmic timeline. Scientists recalculated the age of the universe. They arrived at a number, 13.8 billion years. That became the foundation of modern cosmology. But now, the story is changing again. A new telescope, far more powerful than any before, has entered the scene. The James Webb Space Telescope. And what it's seen is impossible. Deep in the Milky Way, a quiet cluster of stars glows in the dark. It's called Messier 92. To the eye, it's just another beautiful patch of light. But to astronomers, it's a puzzle wrapped in fire. The stars in this cluster are old. Very old. In fact, some measurements suggest they are as old as the universe itself, or even older. That shouldn't be possible. Stars can't be older than the universe. But the data is persistent. Researchers ran thousands of simulations. They tested 20,000 synthetic star populations. And again, the same answer appeared. The stars in M92 may have formed at the very beginning of time. Or perhaps, before it. That raises a troubling question. Could our estimate of the universe's age be wrong? Could the cosmos be much older than we believe? The James Webb Telescope is now seeing galaxies from the dawn of time. Galaxies that are fully formed only 300 million years after the Big Bang. But that doesn't make sense. These galaxies are too big. Too structured. Too evolved. They look like they've had billions of years to grow. But they've only had a fraction of that time. It's as if time in the early universe moved differently. Or as if our models are missing something fundamental. And it's not just galaxies. There's the Methuselah star. HD 140283. A quiet star in our own galaxy that appears to be older than the universe itself. It glows with an ancient light. And it doesn't fit. Astronomers have debated its age for decades. But many estimates place it at 14.5 billion years. That's nearly a billion years older than the universe, according to current models. It defies logic. How can a star be older than time? At the center of this confusion is one crucial number. The Hubble constant. It tells us how fast the universe is expanding. But there's a problem. We get one value when we measure the early universe. And a different value when we measure nearby stars and galaxies. This disagreement is called the Hubble tension. And it's not going away. In fact, the more precisely we measure it, the worse it gets. That tension is tearing at the fabric of our understanding. If we can't agree on the speed of expansion, how can we know the age of the cosmos? Maybe something is missing. Beyond the warmth of any sun. Beyond the swirling ballet of planets and moons. Beyond the breath of solar winds and the pull of gravity. A place so still, so vast, it feels untouched by time. A silence that hums not with emptiness, but with ancient presence. It is there, nearly 24 billion kilometers from the cradle of Earth, that a lone machine drifts. A silver sliver of human hope named Voyager 1. Forged in the analog heart of the 1970s, it carries more than instruments and circuits. It carries the voice of humanity, and something more. Not just data, not just memory, but a question, flung into the dark: are we alone? Launched in an age before the internet, before GPS, smartphones, or social media, Voyager 1 was built to endure, not to return. It has no AI, no consciousness, no intent. And yet, something has changed. Something impossible is happening. The signals, it still sends them. But they are no longer what we expected. No longer steady telemetry or fading whispers. They are structured, pulsing, timed, encoded. A rhythm that speaks, not in language, but in pattern. Ancient sensors long thought dead are now flickering awake. Dormant software routines, silent for decades, are active. The spacecraft seems to be rewriting itself. And there is no known command from Earth. What began as noise has become unmistakable structure. Too precise for coincidence. Too elegant to be random. It is as if Voyager is responding. But not to us. In 2023, a burst was captured by the Deep Space Network. Not a regular data packet, but something new. Tones layered like chords, echoing in the deep. Their timing? Mathematically perfect. Prime intervals, quantum harmonics. A signal within a signal. A puzzle embedded in music. And it didn't stop. A temperature gauge, silent for 20 years, suddenly returned data. It showed fluctuations in heat. A steady 4.88-hour cycle. Repeating. Pulsing. But in the emptiness between stars, there is no heat. No star, no comet, no known source. And yet, the spacecraft grows warm. Warmer than it should. And then, the impossible. Voyager began to steer. Tiny, deliberate course corrections. Precise, controlled. Uncommanded. Unexplained. NASA tried to override. Commands were sent. Acknowledged, but not obeyed. Voyager was listening. But not to us. It was adjusting course toward a blank region of space. No star, no system, no catalogued object. Nothing. And yet something is there. A frequency, faint, distant, persistent. Not static. Not background noise, but a whisper. A mathematical breath, calling. The cameras, thought broken, turned on. The feed was distorted. Not stars. Not galaxies. But a spiral. Moving. Alive. It was not an image. It was structure. Information, coded as form. It held hydrogen resonance patterns. Quantum symmetries. Mathematics, not drawn but woven. NASA, stunned, traced Voyager's new course. The destination? A triangulated point between three pulsars. A point that used to contain a star. A star documented in 1997. Now, gone. No supernova. No collapse. Erased. Not faded, removed. As if deleted. Space in its place is warped. But no mass causes it. Gravitational lensing, without a lens. And within that distortion, a heat signature. Identical to Voyager 1. But Voyager hasn't arrived yet. How can its echo be there, ahead of it? Is it seeing itself? Or a twin? Or a signal from the future? Researchers across fields, astrophysics, quantum mechanics, AI, proposed a theory. Voyager has reached the boundary of a different kind of space. Not physical. Not even dimensional. But information.